with whatever is stored in the location that the pointer points to. That's load from address. It dereferences the pointer. So suppose on top of the stack we have a pointer to address 25. Load from address will pop this pointer off and push on this number. So it will replace this pointer with this number. Right? So before and after. Let's see that again. Once again, before and after. Like that. So it replaces the pointer with what is stored in the location that the pointer points to. Now we have a number of instructions here that are described here. So in each case, we pop two things. Pop I, pop J, and push J op I. Now, here, the difference between these two and those is that in these cases, the things you pop are integers, whereas here, the things you pop are Boolean values. But the instructions work the same way. And the thing you push could be Boolean or integer. If it's Boolean, then 1 represents true, 0 represents false. So let's take a look at example sub. So we've got 3 and 12 on top of the stack. So pop off 12, pop off 3, and push on 3 minus 12, which is minus 9. So before, after. Before, after. Right? So you pop off two things and push on the result of applying the operator to those two things. Let's look at another example, LE. Pop off 12, pop off 7. Push on 7 less than or equal to 12. LE means less than or equal to. So 7 is less than or equal to 12, so you push on true. So pop off 12, pop off 7, push on 1. True. Right? 7 is less than or equal to 12, right? Before, after. Before, after. All right, and or work similarly, right? So you pop off 0, pop off 1, push on 1 and 0, which is 0, of course. So before, after. Before, after. Change sign. That just changes the sign of what is on top of the stack. So minus 12 becomes 12. And not. That does Boolean negation, changes a 1 to 0 and a 0 to 1. So if you have 1 on top of the stack, that gets changed to 0. If you had 0 on top of the stack, that would change to 1. All right, so now let's translate the method G. All right, so we're going to translate this method. So we're talking about this method. So let's translate this. So first of all, we have to know, well, let me first remind you that the code generated begins with init stack frame 1, right? We did this already, right? Because there's one location used for local variables in the method's body. So init stack frame 1, and the thing ends with return 2 because there are 2 parameters. Also, we need to know the offsets for Z, not Z, I'm sorry, for Y, D, and E. So Y is a static variable. So Y has address 1. And we need to know Y has address 1. And we need to know that D has offset -3 and E has offset -2, right? So this is from the, I'm sorry. This is from the memory allocation rule for formal parameters. Right? So, all right, so let's quickly get back to what I was doing. All right, so Y is given static address 1. Z, although we don't really need to know this, but Z is given offset +1. E is given offset -2, and D is given offset -3. Okay. So as I mentioned earlier, the code begins with init stack frame 1 and ends with return 2. So we know that already. No code is generated for this declaration because there's no explicit initializer. No explicit initializer means no code generated. Right? So Z is not in fact initialized. It's a local variable. All right. First, we push a pointer to Y. Okay, so push stat add 1, right? Because of the 1. Push stat add 1. Now we need to push a pointer to D and then dereference the pointer because we want to get the value of D on the stack, right? So push lock add -3. Push local address -3. Right? Push local address -3. Like that. And now we want to dereference the pointer to replace this pointer with the value of D. So load from address, right? Like that. So D's value is now on top of the stack. Now we do the same thing to E. So push local address -2. Push lock address -2. Dereference the pointer using a load from address. Right? Load from address. So now E's value is on top of the stack. And now we can actually do the division. So div. So we pop off E's value, pop off D's value, and push D divided by E's value. Finally, we want to save this into Y. So save to address. Like that, right? So pop off D over E's value, pop off the pointer to Y, store D over E's value into Y's location. And so what we've just done is what is shown here. All right, so we've just hand translated the method G into those instructions. Now let's look at this return statement here, right? This turquoise or cyan statement. So now we need another code generation rule. So how do you translate a return expression statement? Well, you need to translate it into code that leaves the value of the expression on top of the stack. That is so the caller will be able to find the value you're returning. And then you need a return K, just as in the case of the void method, because where K is the number of parameters the method has. Where K is the number of parameters. So we're going to need code that leaves the value of this on the stack, and then we need a return 3. Why return 3? Because F has 3 parameters. All right. So what is the address of Y? Well, I hope you still remember. It's going to be static address plus 1. Now, what about A and U? Well, let's take a look. C gets -2, offset -2. B gets offset -3. A gets offset -4. V gets offset plus 1. W gets offset plus 2. U gets offset plus 3. So A gets -4. U gets plus 3. Those are stack frame offsets. So A is given offset -4 in the stack frame of F. U is given offset plus 3 in the stack frame of F. All right, so now we're ready to translate. So the generated code must leave this on top of the stack. So first push Y onto the stack. So push a pointer to Y. Push stat add 1. Load from address to dereference the pointer. Push a pointer to A. Push lock add -4. And then dereference the pointer. Push lock add -4. Load from address. Now get U's value onto that. Now you might be wondering why you don't do subtraction immediately. That's because a mod has higher precedence than minus. So we need to work out the value of this first. So we need to get the value of U onto the stack because mod has high precedence. So push local address plus 3 and load from address. Right. And now we do the mod to get the value of A mod U onto the stack. Right? That's the mod. And now we can do save to address, not say sub, to subtract this value from this value and leave the result on the stack, right? So sub, right? So that will leave this value on the stack. And now, so that's the code that leaves the value of this thing on the stack. And now we need the return 3, right? To return control to the core, like this. All right, so what I've just done is I hand translated. So I've done this, so 51 to 59, right? That's what's just been done. All right. parameter passing. So sub first, no, because of precedence, right? So what operator is applied last? It's the minus, because minus has lower precedence than a mod times the divide. Okay, so sub must be done last in this when evaluating this, right? Okay, let's continue. So what code does the compiler generate to leave F21, 22, 23's value on top of the stack? Now remember, when F returns control to its caller, this code will be executed, right? So this is executed, so this code is executed, and so this code here is going to leave this value on top of the stack. So this code is responsible for leaving the returned value on top of the stack. So all we need is to pass the parameters. So let's see how that is done. So you need code that leaves the value of the first argument on the stack. Why is that not? Code that leaves the value of the first argument on the stack, then pass param. Code that leaves the value of the second argument on the stack, then pass param. And so on for all the parameters. And then finally, we need to call stat method the address of the first instruction in method F's code. Now, we saw earlier, the first instruction in method F's code is 34 in its stack frame 3, right? Because that's the first instruction after the stop. So we're going to want call stat method 34, right? Call stat method 34 to transfer control to here. All right, so let's see this again, right? So push num21, pass param. Now to pass 22, push num22, pass param. Now to pass 23, push num23, pass param. And now we need to call stat method 34, like that, right? To transfer control to F's code, right? Like that. Now, how do we translate this print? Well, first we have to evaluate this and then print it out. So first, push a pointer to y. All right, y is given data memory address 1. We've seen that a few times now. So push stat add 1. Right? Then load from address to dereference the pointer. Now we need the code that leaves the value of this on the stack. Now we've already seen that, right? That's from the earlier slide. So we've done that already. And now we just need an add instruction to add those values. So add, right? And so that leaves this value on the stack. Now, how do we print it out? Well, this is where we need a write-int instruction. So what does write-int do? A write-int pops a value off the stack and writes it out like this, right? Pops a value off the stack and writes it out. Right, so that's write-int. But it says print line. So write line on. Now let's do one more example. So what is generated for this call? So again, we have to pass parameters and do a call stat method. So push num17, pass param. Now, what about passing this parameter? So push stat add 1, right? Load from address, pass param. Now, what about this? Well, you have to get x minus y onto the stack, right? So push stat add 0 because x gets address 0, right? Load from address, and then push stat add 1, load from address, then sub, and then pass param, right? Like that, right? So now we have passed all the parameters. Now call stat method 34 to actually transfer control to F. But there's a subtle point here, and the subtle point is that this is a standalone call. Right? So we don't want the value that's returned. So we have to throw away the value that's returned. So we need discard value. All right? So discard value throws away a value from the top of the stack. Discard value like that. Now, why do we need it? Because we don't want the value that F returns, right? Because F returns a value, we don't want it. So we must discard it. Okay, so this is actually not a bad place to stop because we're out of time. And next time, we will start with 91. I'm going to post this slide these slides as well, so you can read them before our next class. But in the code generation rules, we've actually reached code generation rule 9. The example I just showed you with the discard value is actually part A of this. And on Wednesday, we'll start with parts B and C of code generation rule 9. And those parts B and C of code generation rule 9 will be illustrated by this example beginning on slide 91. There are 10 slides there that you might want to take a look at before Wednesday's class. So I'm going to post all these slides tonight. So those of you who have a chance, read the slides. In addition to the slides that have actually been presented, also read the slides from 91 through 100. But on Monday, we will start from slide 91. That's this slide here. And we will talk about the code generation rule 9, parts B and C. Okay. Do we need any more? You definitely need more information to finish TinyJ assignment 2. Yeah, I mean, remember the due date for TinyJ assignment 1 is on, I can't remember what it is, but it's later this week. I think I said Thursday, right? I think, no, Wednesday. No, Wednesday. The due date for TinyJ assignment 1 is Wednesday. For TinyJ assignment 2, you aren't expected to start on this until after Wednesday's class. For now, what I strongly recommend you do is to make sure you understand how to do hand translation. Because remember, there'll be 10 points, that's 40% of exam 2, for questions that test your ability to hand translate, right? Assignment 2 is only worth 2 points. So just bear in mind the relative importance of different things here, right? So this assignment here, assignment 2, counts 2% towards your grade. But on exam 2, the hand translation problems count 10 points, 5 times as important. So what I strongly recommend is before you give higher priority to making sure you know how to do hand translation, okay? And so that's why I covered this, in addition to the fact that you actually need to know how to hand translate before you can properly understand what the compiler does. So that's one thing. But another thing is it actually is more important from the point of view of your grade that you actually are able to hand translate. Okay, so it's very important before exam 2 to make sure you understand everything that I covered today, all this stuff, and also what I'm going to say on at the beginning of Wednesday's class on hand translation, and I'll actually have more to say on hand translation probably later on. Okay. Yes, I reckon that's Lindita, exactly. I would suggest that right now your priority should be to make sure you understand the hand translation. Right, because that actually is going to be very important on exam 2. I don't know, December 1. Oh, that was the due date for assignment 2, right? Is that right? Yes. No, that's assignment 2. Due date for assignment 1, December 1. So Cindy is correct. Deadline is Wednesday, December 1. So are there any other questions at this time? On top, yes, you're right. I agree with you, Cindy. December 1. Okay. Are there any other questions at this time? Let me turn the recording off. Stop recording. Thank you, Lindita. Any other questions at this time? Okay, so if there are no, Seth has a question. Should return nothing. What's this? For I in the do diff for I dot sol. So yes, there should be no differences, right? but also make sure you understand the debugging method, right? So that this is for everybody. There's a bit, quite likely Seth already understands this, but I just want to make sure that this debugging method. So I have had at least one person ask me about this, but another person said they wanted to see me, so they may want to ask me about this. Make sure you understand this debugging method, okay? So it's not just about doing the assignment. Sometimes I set exam questions that test your understanding of the debugging method. All right, so if there are no more questions, then I'm going to sign off, and I look forward to seeing you all on Wednesday. Oh, Oscar has a question. No, I'm just saying sometimes I set exam questions like this, so I can't tell you what you will be asked about on the exam. So I would say that the chance that you get a question like this is at probably less than 50%, because I'm not going to, I'm setting 3 exams. So even if I decided to set a question like this, I mean, maybe I would set it for one of the other classes. And it's quite possible that none of the classes will get a question like this. It's just that over the past 10 years, I would say quite frequently I set this question, but usually it would be to just one of the sections I'm teaching that semester. And some years I don't set a question like this at all to any of the sections. So the chance of you're actually getting a question like this, I would say, is less than 50%, but certainly more than 0. But if you get a question like this, it's a fairly easy question, right? I mean, it's not that doesn't require deep thinking. So definitely you should try and make sure that you can answer this kind of question. Okay, so I can't tell people in advance exactly what questions they're going to get, right? So there are lots of possible questions. So this is one kind of question that I've said very many times, right? Maybe over the past 15 years, maybe 25 times, something like that. 25 is probably an over. Maybe over the past 15 years, maybe 10 times. Right? 25 is probably not too much. Yeah, something like that. So I've certainly said it many times. Okay. All right. So if there are no more questions at this time, then I'm going to sign off, and I look forward to seeing you all on Wednesday. So goodbye, everyone.